Stability of carboxylic acids, right? Hello. Stability of carboxylic acid, acidity of carboxylic acids. Hmm? Acidity of carboxylic acids, right? Hello. So I told you carboxylic acid, which is more acidic, means, right? So acidic nature is directly proportional to what term? Minus I. And acidic nature is inversely proportional to plus I. Yes or no? కొంచెం రిప్లై ఇవ్వండి, నాకు అర్థం కావట్లేదు మీరు మాట్లాడేది. రైట్, acidic nature is directly proportional to Ka, right? Acidic nature is inversely proportional to pK. Yes or no? Hello. And I told you at oxygen, wrong, if electron density is less, that is more acidic. At oxygen, if electron density is more, that is less acidic. So that's the reason. So when plus I groups are donating the electrons, right, that's the reason we are inversely proportional to acidic nature. So the last class we discussed all this, right? Anybody having any doubt in the acidic nature? Ka, pKa. Hello. Hello. So can you zoom the border from your end? Hello. You people can't zoom. So the board is okay na? Kanpistunda? Chalo. Right, Nana. Today put the heading basic nature of amines. Basic nature of amines. Sai, vintunnava? Sai. So amines are three types, right? Primary amines, secondary amines, and tertiary amines. So which amines are more basic, Nana? Anyone? Which amines are more basic? Which is more basic nature? Nana? Primary, secondary, and tertiary amines. Huh? So what exactly the basic nature? If they donating lone pairs more and more, right, that is more basic nature. So actually it is R is the plus I nature, right? In this case plus I, two plus I groups. In this case, Nana, 3 plus I groups. See, for example, if I'm getting the money from only one source, so shall I spend and mention I donate more and more? Or if I'm getting the money from two sources, if I'm getting the money from three sources, so where I'll get more donating? Third case, right? So obviously what? 3 degree, then 2 degree, then 1 degree. But the thing is, this is applicable only in gaseous state. Only in gaseous state. Only in gaseous state. It's applicable only in gaseous state. 3 degree, 2 degree, 1 degree. It's applicable in gaseous state. So YouTube is JN Chemistry. What channel? Done? Hello. Next, Nana. In aqueous case, three effects are applicable here is, right? One is inductive effect. According to inductive effect, we know 3 degree is more stable than, more basic than 2 degree than 1 degree than ammonia, right? But here one more important thing is coming, that is solvation effect. Which one? No? Solvation. Solvation effect is telling opposite. Ammonia is more basic than 1 degree, then 2 degree, then 3 degree. And one more effect is applying here is steric hindrance. Steric hindrance. According to steric hindrance, more bulkiness. If the bulkiness increases, the basic nature is decreases. Means, so 3 degree, like bulkiness increasing. So what exactly happens? I'll explain one by one. Already I explained inductive effect. So 3 degree means it is directly attaching with the 3 plus I groups, right? So if it is 3 plus I groups, that is more basic, because the more electrons are coming from, right? Then say 2 degree and 1 degree this is. But exactly in the solvation effect, in aqueous case, solvation effect is important, right? Solvation effect is important. So what exactly solvation effect I'll discuss. Solvation ante addition of water. Okay, I'll explain that.
Okay, sir.
Third one is steric hindrance. Steric hindrance means bulkiness. Right, I'll explain one by one. So in case of solvation effect, means what? Addition of water. For example, if I'm taking ammonia, 3 hydrogens are there, right? So 3 water molecules now. Forming the hydrogen bond with ammonia, okay? 3 water molecules in case of ammonia. But whereas in case of primary amine, or NH2, right? In case of secondary amine, in case of tertiary amine. Here is 2 water molecules are bonding with hydrogen bonding. There is only 1 water molecule. In case of tertiary, there is no. Okay. In these 3 cases, 4 cases, which is more solvated? Right? More number of water molecules associated. Which one? NH3. Then here is 2. Here is 1. So in the aqueous case, ammonia is more stable. Which one? More stable means obviously more basic. More stable means what, Nana? More basic. So try to understand. So for example, 2 cricket men are there, A and B. Imagine A plays 4 runs each ball. B is 1 or 2 runs each ball. Let me know who is good batsman. A. Right. So imagine A will out within a over. Within a over he will out, but B will play consistently up to, right, 10-20 overs. So now let me know who is good batsman. So even though he is giving late, but stable, is more stable in the crease, right? So that's the reason. Same thing, ammonia, when we compare with tertiary amine, it's giving the less electrons, but it is more stable in the aqueous case. అర్థమవుతుందా? తక్కువ ఎలక్ట్రాన్స్ ఇచ్చినా కానీ ఎక్కువ స్టేబుల్గా ఉంటుంది. ఎక్కువ స్టేబుల్గా ఉంటే ఒక్కొక్క రన్ మెల్లగా ఎలా అయితే మనం కొడుతున్నామో అలా కొడుతుంది అన్నట్టు, రైట్? సో అందుకోసమని నెక్స్ట్ ఎక్వస్ కేస్లో మారిపోయింది. గాట్ ఇట్? హలో. Next, that's the reason ammonia is more basic than primary amine, then secondary amine, and the tertiary amine. Exactly opposite to inductive effect. Exactly opposite to inductive effect. Exactly opposite to inductive effect. Done? Next, third one is steric hindrance. Still anybody having any doubt here? Next, steric hindrance. What is steric hindrance? In the chemistry, steric hindrance, one of the important thing, bulkiness, right? So we will discuss in SN1 case. SN1 case also, because of the bulky groups, the nucleophile can't approach the back side. So I already explained some people, right? Let it be. So for example, try to understand if I am taking the tertiary amine, some bigger one. One methyl group is there, so one ethyl group, right? One something other group. So try to understand now. So nitrogen is having the more and more electron density right now. It's readily wants to donate the electrons, but if it wants to donate, someone has to come and take the electrons, right? But nobody can't approach because of this bulkiness. Imagine, try to understand, who is the powerful and rich person in the Telangana, for example? Who is the powerful person? Who is the powerful person in the Telangana state? Who is the powerful person? CM. Obviously, CM is the powerful chief minister. So CM. So the total money is with him. So if you are facing any problem with your education, so if you are unable to pay tuition fees, you can go and approach him. Or you are facing any health issues, right? Sir, I went to hospital, for example, this 2 lakhs was spended. So you can go and approach 30 to 50, 60%, he'll compensate. Really, that is where called a CM relief fund. Okay, you can go and ask him. The problem is he's having plenty of money. The problem is you can't approach him directly. If you go to the CM office, they'll ask you, are you having the appointment? So those are the security systems like that. So even though nitrogen wants to donate the electrons like a CM, so we can't approach the nitrogen because of bulkiness, because of the security of these groups. That is we are called as steric hindrance. Steric hindrance nothing but bulkiness, bulky groups. So throughout the chemistry, this word is coming. Okay, bulkiness is coming. Got it? Right. Because of this, when the bulkiness increases, automatically basic nature what happens? Decreases. So based on these 3 reasons, Nana, which one? So solvation effect and inductive effect and steric hindrance. So we will give you a new order based on that. Imagine, for example, you are preparing for one exam. You didn't prepare, so first you didn't attend the classes. Okay, what happened? You didn't attend the class. Okay. Second, you prepared well. You prepared well. Third case, so the exam day you got fever. You got fever. So out of 100 you got 60 marks out of 100. Imagine that 60 marks because of what? In these 3, which one? The 60 marks you got by resultant of these 3. Might be if you attended the class, might be the score might be increases. So because of you prepared well, of course 60. If that day fever won't come, so might be this increases. Right? Who are controlling this 60 means all these 3. Yes or no? Particularly here also the basic nature of amines also, right, affected by these 3. So experimentally they decided that. So this is the important thing, Nana. So for R group, if R group is methyl group, so this everyone should remember this. Okay, 2 degree, then 1 degree, then 3 degree, and ammonia. How it came because of combination of all these. So we need to remember, if you are changing the methyl R place, if you are methyl group, ethyl group, for example, if you are changing the ethyl group C to H5, the order is changing now. 2 degree, then 3 degree, then 1 degree, then ammonia. So this is the order because of combination of all these three. Okay now? So this one we need to remember. Lot of people, right now it's fine. After 1 week or after 10 days they are sitting in the examination. What exactly happens? Right? Ade, idi, ide, adi. So we are in a confusion mode, right? We are in a confusion mode. Right now. To avoid the confusion, I will tell you one small trick. So everyone, you can follow that trick. That is JN trick. So the problem is methyl and ethyl, right, Ram? So now methyl and ethyl, which is smaller and which is bigger? This is small, this is bigger. Clear? And see the order, it is 2 degree and ammonia. 2 degree and ammonia both are same in both the cases. Both the cases, both are same. Only the problem is 1 and 3, 3 and 1. Yes or no? So imagine this is a small shortcut which I am telling you. Small group, right? 1 and 3, which is small, right? Small with small, big with big. Whenever the methyl group is coming, so we need to decide in our mind. Methyl means what? Small or big? Small. After 2, 1 should be coming. So ethyl means what? Small or big? Big. Yes or no? So 3 degrees coming first. Then automatically 1 degree is coming. Got it clear? Easy on the trick? Yeah, because in our group lo entante appudu solvation effect undadu, right? Somewhat steric effect is affecting, okay? But inkoti entante more if the bulkiness increases over there, those will not exist as a gases. Low members are only gases, right? Atla. Clear on the voice, clear on kada? Huh? Yeah. Oh, Holy Land అని కొత్త మైక్ కొనుక్కొచ్చా ఈరోజు మీకోసం. అరే 3 days నుంచి ఎక్స్పెరిమెంట్ చేస్తే ఈ లెవెల్కి వచ్చింది. ఒకరోజు మైక్ పని చేయట్లేదు, ఒకరోజు ఇంతకుముందు కెమెరా పని చేయలే. సో ట్రిక్ ఈస్ క్లియర్, రైట్ ఎవ్రీవన్? Any doubts? So only the thing is, so first I told you in the gaseous state, so by basic nature in the gaseous state 3 to 1 simple. So but in aqueous case what exactly happens, Nana? In aqueous case 3 factors are affecting. One is the inductive effect, solvation effect and steric endurance. So inductive effect is same as it is because plus I groups are increasing, so same. In case of solvation effect, because of, right, hydrogen bonding, it is more stable in the water. This is somewhat less stable. So more stable means it donating more and more electrons. So then this is called as steric endurance. Because of that, so we got the final answer. The final one is 2, 1, 3, right? 2, 3, 1. So how to remember? How we need to remember? Small with small, big with big. This is a trick, just keep in your mind. So anytime if it is coming automatically, because if you are changing this, ethyl will become propyl. The order is keep on changing, right? If butyl, order is changing, but so those number of orders we don't need because that is not in our syllabus. Okay? which is needed for us only. We need to remember that. Okay now. Right. So next, clear anyone? Any doubts? Hello. Next, reactivity of alkyl halides. Reactivity of alkyl halides or haloalkanes, right? Haloalkanes. For example, I'm just taking the 3 degree, 2 degree, 1 degree. So let me know which is more reactive, Nana. Which is more reactive in alkyl halides? Which is more reactive? Hmm? Tell me. Hmm? 3 degree, because generally alkyl halides undergoes nucleophilic substitution reaction. So once it is going, we'll get the 3 degree carbocation. In this case, 2 degree carbocation. It is 1 degree carbocation. So which carbocation is more stable? 3 degrees. So 3, 2, 1. 3, 2, 1. Then Krishna unnava class lo? Krishna. ముఖం పర్లేదు, లైటింగ్ బాగానే ఉందరా? వన్ అంటే next, one of the most important thing right now, so that is reactivity of carbonyl compounds. Write it down. Reactivity of carbonyl compound. Carbonyl compounds means what? Huh? Aldehydes and ketones generally we are called as carbonyl compound. Aldehydes and ketones generally we are called as carbonyl compound. Aldehydes and ketones generally we are called as carbonyl compounds. Which of the following is more reactive? None. They'll ask the question like this: HC double bond OH, or C double bond OH, or C double bond OR. Which of the following is more reactive? Let me know the answer. Which one? ketones. Okay, Thai. Answer.
Third option.
Third option. Okay, Krishna. What is the answer? Formaldehyde, aldehyde, and ketone I gave you. Which is more reactive? Huh? Yeah. Here is the answer is formaldehyde, then aldehydes, then ketones. Why? Vaira. So here is basically, here we didn't have any plus I groups, right? This is one plus I group. This is two plus I group. Before answering this question, we need to know aldehydes and ketones undergoes nucleophilic addition reaction. Nucleophilic addition reaction. First, the nucleophile is coming and attaching over here. Attacking over here. Nucleophile. Why the carbonyl group P double bond, right, Nana? Oxygen is having more electronegative than the carbon. So means what? Oxygen will get partial negative charge, carbon will get partial positive charge. Partial negative charge here is partial positive charge. Nucleophile is which charge? Negative charge. The negative charge coming and attacking the carbon, because carbon is having which nature? Somewhat positive nature. So negative nucleophile, negative charge wants more positive charge or less positive charge? More positive charge. So in this case, Nana, so here no plus I groups, no one is donating. So here is positive charge is somewhat more. But here is one R group is there that is donating the electrons. Automatically the electron density is somewhat more at this carbon. The positive charge is somewhat, whereas in this case two plus I groups are there, right? Automatically the positive charge is decreased, right? Means electron density is more. Here is electron density somewhat less. Here is electron density is very less, right? Electron density is very less at formaldehyde. So generally formaldehyde we are called as superaldehyde. Which aldehyde? Superaldehyde. Superaldehyde means this is more reactive when we compare with all the aldehydes. Why it is more reactive? Because more positive charge at carbon. Why more positive charge at carbon? Because no donating groups. No donating groups. Generally, see in your life also, if you are not supporting, someone is not supporting, the persons are will superpower. They are having they can do everything themselves. If someone is supporting them, so they'll become lazy, right? So in case of here, two things are important. Once again, steric hindrance is coming. What is steric hindrance? What I told. Already this positive charge is very means very less and more electron density. Nucleophile doesn't want to, because already electrons are negative charge, right? Repulsions are there. The point number one. And point number two, because of bulkiness, Nana. Hello. For example, C, can I write like this? CH3, C double bond O, C, H, H. Now only steric hindrance. Madam, the steric hindrance word, once again, I keep on using the word steric hindrance or bulkiness. If the nucleophile wants to attack in this case, right, it's because of bulky nature also. This is the second reason. You could say two reasons. Reason number one, inductive effect. Based on inductive effect, what exactly happens? The two plus A groups are there. Because of that, carbon is having the less electron density. So generally, aldehydes and ketones undergoes nucleophilic addition reaction. If nucleophile wants to attack at the carbon should have less electron density, right? More electrons, right? Less electrons. But here is means more positive charge the nucleophile is expecting. Negative charge wants more positive charge, right? That is the one reason, and second reason is steric hindrance. These two are also for second year guys. This is very important. Once again, you will get these points in aldehydes and ketones chapter. Okay, this is clearly explained by which one? Inductive effect. Clear everyone? Any doubt? Hello, అభిక్షిత్ అర్థమైందా? అర్థమైందా? ఎక్కడ అర్థం కాదు చెప్పు నీకు కానీ సో ఫస్ట్ ఇక్కడ ఇది అర్థం కావాలంటే ఫస్ట్ మనకి 3 ఇంపార్టెంట్ థింగ్స్ తెలవాలి. ఆల్డిహైడ్స్ కీటోన్స్ అంటే ఏంటో తెలియాలి ఫస్ట్, పాయింట్ నెంబర్ 1. And point number 2, they'll undergo nucleophilic addition reaction. Aldehydes and ketones undergoing nucleophilic addition reaction. That is point number 2. Nucleophilic addition reaction means what? Nucleophile is having which charge? Nucleophile, we need to know what is nucleophile. If you don't know the nucleophile, so I could not do anything. Right? Nucleophile means negative charge. So the negative charge one is coming and attacking to the positive charge. Here is. So when it is attacking, carbon should have the more positive charge, right? Hello? And less crowding, less steric hindrance also is there in case of formaldehyde. But whereas in case of aldehyde, one plus I group is there. Whereas in ketones, 2 plus I groups are there. Okay, na? Dana? Still, if you have any doubt, let me know, please. మీకు అర్థమవుతుందా? నేను తర్వాత చూద్దాం. Shall I? Yeah. So right now we discussed acidic nature of carboxylic acids. Even acidic nature of alcohols also we can explain. Write it down. Acidic nature of same like carboxylic acids. Acidic nature of carboxylic acids. Acidic nature of carboxylic acids. Acidic nature of carboxylic acids. So alcohols also 3 types, right? Primary alcohols, secondary alcohols, and tertiary alcohols. For example, CH3CH2 OH, this is primary alcohol. CH3CHOH, secondary alcohol. Tertiary alcohol. Pranay, tell me which alcohol is more acidic? Why tertiary? So which is more tertiary? ఇప్పుడు ఆన్సర్ చెప్పండి. ఆన్సర్ నా దగ్గర నుంచి వచ్చేసి okay. Any other answers? Primary. So primary is more acidic than secondary than tertiary. Why primary? I told you same reason. At oxygen, electron density should be less. that is more acidic. In this case, right, 2 plus I groups, but in this case what exactly? 2 are additive effect. Both are, for this carbon only one methyl group is donating, but for this carbon 2 methyl groups. In this case 3 methyl groups are donating. So means where the electron density is maximum? At tertiary. So if the electron density is maximum at alcohol, that is less acidic, the same manner which we discussed in the carboxylic acids. So here is also same nature, acidic nature is directly proportional to minus I. Acidic nature is inversely proportional to plus I. Avunu. Primary is more acidic, greater than చూపించాను నేను. Less acidic, very less acidic. Most acidic ఏంటి? Primary. 1 degree, then 2 degree, then 3 degree. Okay na? Hello. ముకుంద్ వింటున్నావా? అడగట్లే క్వశ్చన్స్. బోర్డు క్లియర్గా ఉందా? నేను అడ్డం వస్తున్నానా? కొంచెం పెద్దగా రాయినారా? సరిపోద్దా సైజ్? సైజ్ సరిపోతుందా? కొంచెం పెద్దగా రాయినా? ఓకే. సో మీరు ఎవరెవరు ల్యాప్టాప్లో చూస్తున్నారు, ఎవరు మొబైల్లో చూస్తున్నారు? ల్యాప్టాప్లో చూస్తే బాగుంటుంది కదా క్లాస్. కొంచెం ట్యాబ్లో కానీ ల్యాప్టాప్లో కానీ చూడండి క్లాస్. వీలైతే పెద్ద స్క్రీన్ వేసుకోండి. 55 inches 65 inches స్క్రీన్లో మీరు కనెక్ట్ చేసుకోండి. రైట్, ఎంజాయ్ ద బిగ్ స్క్రీన్. సినిమాటిక్ ఎఫెక్ట్స్, రేపంచే ఎఫెక్ట్స్ పెడదాం మనం కూడా. కొంచెం మ్యూజిక్ పెడదాం, ఎంటర్టైన్మెంట్ చేద్దాం. సో డోంట్ ఫీల్ లైక్ ఇట్స్ నాట్ ఏ యూట్యూబ్ క్లాస్. సో మీరు నా ముందు కూర్చున్నారు, రైట్, మీరు నాతో మాట్లాడుతూ ఉండండి, డౌట్స్ అయితే అడగండి, ఓకేనా? డోంట్ బిహేవ్ లైక్ ఏ యూట్యూబ్ క్లాస్, లేకపోతే క్లాస్ రూమ్ క్లాస్లో కూడా మీరు ఫీల్ అవ్వద్దు. నార్మల్ క్లాస్లో ఒక 50 మెంబర్స్ ఎక్కువ ఉంటారు కదా, మాట్లాడాలంటే సార్ మాట్లాడి, నేనే ఇక్కడ మాట్లాడండి రా బాబు అంటే ఎవరు మాట్లాడలే. ఏం చెప్తున్నా? అనీష్ వింటున్నావా? అనీష్, సో పొలారిటీ ఆల్సో వీ కెన్ ఎక్స్ప్లెయిన్, రైట్? అదే కెమెరా పక్కన పెట్టేసి కొంచెం అవసరం లేదు. కంఫర్ట్ ఇరికి కూర్చుంటున్నారు కదా, కొంచెం ముందుకు వచ్చేసి. రైటా? So this is all about, this much of is enough about the inductive effect, right? Inductive effect. Then we will discuss the next important thing is resonance. Resonance in the part only the mesomeric effect. So when benzene ring is coming, so when you are doing the something about the benzene ring, that is we called as mesomeric effect. But first we need to know resonance, one of the important thing, resonance and hyperconjugation. So particularly try to understand CH2 double bond CH, for example CH2 plus. In case of inductive effect, the electron migration effect or the electron migration takes place in the sigma bond. I mean sigma bond means single bond means, right? C some X, right? The electrons are just, and this is very weak effect, right? Inductive effect is weak, but whereas in this case resonance is strong, right? For example, you needed money, మీకు పైసలు కావాలా, right? You need money. You have two types of friend. One is resonance, one is inductive effect. For example, you need 10,000 rupees, imagine. So resonance వాడు ఏమంటుండో చలంటే ఇమీడియట్గా ట్రాన్స్ఫర్ కొట్టేస్తాడు, 10 అని వచ్చేస్తుంది మెసేజ్, రైట్? అరే ఐ నీడ్ సమ్ 10,000 రూపీస్ అనగానే టక్కున ట్రాన్స్ఫర్ చేసేస్తాడు. ఎవరు? వీడు. ఇండక్టివ్ ఎఫెక్ట్ ఉంటాడు. అరే 10,000 అవసరం ఉన్నాయి కదా, ఎప్పుడు? రేపు కదా, కానీ నా దగ్గర ఉన్నాయిరా, నాటికి వచ్చిస్తా, నువ్వు ఏం టెన్షన్ ఏం పడకు, నీ దగ్గర ఉన్నాయనుకో, రైట్? దట్ మనీ ఈజ్ విత్ యూ, ఓకే? మనీ ఉన్నాయి, ఇస్తాగో, తీసుకో, చూడు ఉన్నాయి, చూడు నా జేబులో ఉన్నాయి, కనిపిస్తున్నాయి కదా, దిస్ టైప్ ఆఫ్. సో నౌ ఇన్ దీస్ టూ కేసెస్, సో విచ్ వన్ వుడ్ యూ లైక్ మోర్, రైట్? వీడు అరే ఉన్నాయి రాగో చూడు ఇస్తున్నది. That exactly happening the inductive, but resonance is somewhat permanent. Transfer of electrons takes place. Which electrons? Pi electron. Yes, pi electrons are transfer takes place. CH2 plus means what are already vacant of carbon is one vacant p orbital is present at here. What is there? When vacant p orbital. How we know that, how the pi bond is forming? How the pi bond is forming? Because of lateral overlapping, because sidewise overlapping pi. Imagine this is positive charge and this is negative charge are side by side. What exactly happens, right? Bit attractions are started, opposite charges are attracted, right? So the electrons are moving towards the positive side. Automatically what exactly happens here? What exactly happens, Ra? Huh? Here is also the bond is weakens. For example, I am strong this side, right? I am just moving this side. Right. So if the bond is moving this side, automatically what exactly happens? Huh? It's weakens, right? This exactly happens, Nana. So particularly CH2 double bond CH, when CH2 plus sigma bond and pi bond, which is weak and which is strong? Which bond is breaking takes place? Pi bond, because sigma is strong, pi bond is weak. So directly I am just writing the pi bond is migrating to here directly. So we can do the stepwise, but no need. Directly I am writing CH2 CH double bond CH2. Here is the positive charge now. Once again, what exactly happens? Huh? This pi bond is once again heterolytically. We'll get the original structure. So the first one is coming to second one, second is forming the first one to second, second to form first. So particularly we can write like this: CH2 CH2. The electrons are moving here and there, partial positive here, like the electrons are moving, that is we are called as resonance hybrid. Resonance hybrid. resonance hybrid is takes. Okay, resonance hybrid. More resonating structures, compound is more stable. Write that point also. The compound is having more resonating structures, compound is more stable. Compound is more stable. The compound is having more resonating structures, compound is more stable. Try to understand. So resonance takes place when the carbocation is present, right? And alternate double bonds. Alkenes are three types. Write it down. First, alkenes are how many types? Three types. Conjugated double bonds and cumulative double bonds. Cumulative double bonds means what? Side by side. And one more type of double bonds are there. Those were called as which one? Huh? Anyone? Isolated double bonds. Conjugate, cumulative, isolate. Isolate double bonds. Isolate means here is double bond and somewhere double bond is there and somewhere isolated. This is cumulated. This is conjugated or alternative. Alternate means what? One after one, one after one, right? Alternative. So resonances takes place in which case, Nana? Resonances takes place in conjugate or alternate double bonds. But in case of cumulated and isolated cases, resonances won't takes place. Resonances won't takes place. That resonances won't takes place. So in case of conjugate double bonds or cumulative double bonds, how the resonances takes place we'll discuss. No? Same run. Here is pi electrons are transferring. One of the pi bond here is, imagine, undergoes heterolytic cleavage, breaking to here. So generally carbon is having always how many bonds? 4 bonds. If it is the bond is coming here, this carbon already is having the 4 bonds. So 5 bonds is possible? No. So automatically what exactly happened? This pi electron is coming to up to here. So what structure we can write? CH2, this positive charge, CH, double bond, CH, CH2, negative charge. First we'll get the structure. Once again, what exactly happens? Once again, this negative charge is coming here, right? We'll get the original structure, right? This we are called as CH2, CH, H, H2. The electrons are moving there. That is called as resonance hybrid. Resonance hybrid. They are called as resonance hybrid. Resonance hybrid. Start this. కొంచెం వరకు సరేనా? Now Next, this resonance is takes place. For example, CH2 double bond CH2 radical. In this case also resonance is possible. Radical means it's undergoing homolytic cleavage. Okay, it undergoes homolytic cleavage, and the electrons are moving here. So we'll get the structure is like this: CH2, CH double bond CH2. Here is the radical. Once again, what happens? This bond homolytic cleavage takes place. Get the original. If carbene ion is also present, that case also resonance takes place. CH2 double bond CH, CH2 minus negative charge. Right, exactly in this case what exactly happens, Nana? This negative charge coming here, pi bond migrating to here, right? Then CH2 negative charge, H double bond. Okay, now I'll give you some structures. So one more important thing is the compounds which are having the more resonating structures, compound is more stable. Why? Why that is more stable? Anyone can give me any examples? Of course, if you are already with my class, so no need to tell. If you are new, then you can tell. Yeah, tell me why compounds are more stable, Nana. For example, try to understand. In these two cases, which is more stable? Huh? B is more stable than A, because in the B, conjugate double bonds resonance is present. Yes or no? Huh? For example, try to understand. The option A, option B. In these two cases, Nana, which is more stable? B is more stable. Why B is more stable? Right? Resonance is taking place from the more resonating structures we can get. In this case, 1. For example, if I am giving some option C, that is less stable, right? CH3, CH double bond, CH2. In this case, resonance is not possible. Resonance is not possible, right? Hello. Now, if the more resonating structures, compound is more stable. Fine. Why? Krishna, why? Krishna. Now, the compound is having more resonating structures. Why compound is more stable? Mukund? Mukund? Right రా, ఎందుకంటే try to understand. You are in a room రా, for example. You are house arrested, right? And second case, you are having the freedom. Freedom is restricted to only you need to go college and you need to come back. So here is no college, nothing, no need to go. But in this case, only you need to go college and come back. The second case, you need to go college, you can go friend's house, you can go, right? Movies also, anything is possible. In these three cases, where the persons is more stable, huh? The people who are having the more stable. For example, the house arrested cases, no resonance, means no movement, no migration. But it is only restricted migration. It is free migration, right? So, for example, we will go to the college, we will stay forever or college, in the college or will back to home. So here is the resonating structures is forming and backing home, right? More flexibility, more freedom is there. So that's the reason how we will feel as a human being, how the human being is feeling. The same method, the molecules also is like more resonating structures compound is more stable. Okay, na? So now write the resonating structures for these following compounds. Apida, hello. ఎవరైనా యూట్యూబ్లో ఓపెన్ చేసి జేఎన్ కెమిస్ట్రీ అని కొట్టండి. జేఎన్ కెమిస్ట్రీ అని లైవ్ స్ట్రీమింగ్ అవుతుందా లేదా చూడండి. లైవ్ స్ట్రీమ్ వస్తున్నాయి. కంప్లీటెడ్. I'll give some more. అనీష్ వింటున్నావా? అనీష్ దేంట్లో వింటున్నావు నువ్వు? స్ట్రీమింగ్ అవుతున్నారా మీకు? వస్తుందా యూట్యూబ్లో? వస్తుందా రావట్లేదా? లేదా ఛానల్ మీకు దొరకనట్టుంది. అంటే నా పాత ఛానల్ కాదు, కొత్త ఛానల్ ఇంకోటి ఉంది. జేఎన్ కెమిస్ట్రీ. వస్తుందా? ఒకసారి ఆ లింక్ షేర్ చేయండి. చూపిస్తా. నువ్వు మొబైల్లో చూస్తున్నారా? ప్రణయ్ మీకు కనిపిస్తుందా? ఇట్లా ఆ బోర్డు పైన చెప్తే బాగుందా, ఇలా బాగుందా? దొరకలేదురా నీకు? అరే ఏమని టైప్ చేస్తారా మీరు సాయిరిది? జేఎన్ కెమిస్ట్రీ అని టైప్ దొరకట్లేదంట. పెట్టు ఒకసారి. యూట్యూబ్ ఓ సముద్రం, దాంట్లో మనం ఎక్కడో ఉంటాం. ఎవరు పడితే వాళ్ళు స్టార్ట్ చేశారు యూట్యూబ్. అవునవును, వస్తుంది వస్తుంది. ఎవరు పడితే వాళ్ళు స్టార్ట్ చేశారు. చాట్ దాంట్లో ఉందిరా దాంట్లో. సో ప్రణయ్, ఏ నెంబర్ కావాలి నీకు? తను shall we start that ionic equilibrium? సో రేపు ఇది కంటిన్యూ చేస్తాం నేను. సో ఇంపార్టెంట్ టాపిక్, డోంట్ మిస్ దిస్. రైటా? సో లాస్ట్ క్లాస్ వాట్ వీఆర్ డూయింగ్ now? హలో హాయ్, లాస్ట్ క్లాస్ ఎందాక చేస్తాం మనం? So I told you derive those things, right? How many of you did that? Shall I explain or no need? The derivations. The derivations which I gave you in the last class, right? Huh? The derivations which I gave the last class. How many of you prepared and came? Write a question. Calculate the pH of a sample. Calculate the pH of a sample. Calculate the pH of a sample of soft drink